water. It is Earth's defining feature. Other planets besides our own have towering mountains and vast deserts. But only on Earth do we find this: entire oceans of water in liquid form covering much of the planet's surface. Water shapes our world. It dissolves rock, moves energy around the globe, and helps make our climate livable. But most important of all, water lets chemicals mingle, including those chemicals that are crucial for sustaining life. Quite simply, without water, life as we know it would not exist. Water is so important to life on Earth that finding it has become a key goal for scientists looking for life elsewhere in the solar system and beyond. In effect, we have become cosmic dowsers, feeling around for hints that even now, water is flowing somewhere out there. The quest for water has led us to the places that at first glance seem to resemble Earth the most. Torrid Venus and desolate Mars. But surprisingly, the strongest evidence we have that water is present in liquid form elsewhere in our solar system comes from a world that is utterly different from our own. This is Enceladus, a tiny frozen moon of Saturn located 1.5 billion kilometers from the Sun. Although it is just one of dozens of moons orbiting Saturn, scientists have long suspected that there is something special about Enceladus. For starters, it has the brightest surface in the entire solar system. And another curious detail, Enceladus travels around Saturn embedded within a faint and diffuse band of particles known as Saturn's E-ring. Astronomers have long suspected that the E-ring is related somehow to Enceladus. But how? The question would be answered in 2005, when NASA's Cassini spacecraft began the first of several close passes of Enceladus during its ongoing exploration of the Saturn system. In some areas, the surface is clearly ancient, marked by craters that have accumulated over billions of years. But toward the south pole of Enceladus, the surface features tell a very different story. Here, the landscape is dominated by a strange pattern of linear grooves. In July 2005, Cassini was swooping in for a closer look at this area when it spotted a dramatic series of 4 deep fissures. Scientists nicknamed the strange markings the tiger stripes. During the same flyby, one of Cassini's instruments detected signs of a gaseous material above the moon's south pole. The gas was mainly water vapor. These clues made it clear that something truly unique is happening on Enceladus. So when Cassini next encountered the moon in November of 2005, mission controllers commanded the robotic probe to swivel around and capture an image of Enceladus backlit by the sun. The result was this incredible image showing jets of water vapor spewing from the south polar region of Enceladus. These jets must be the sources of the E-ring that surrounds Saturn, and they are among the most exciting revelations of the entire Cassini mission. Captured in the sun's glare, the jets look like geysers of icy mist. Enceladus, once expected to be a cold and dead moon, seems to have a warm and geologically active interior, and the results can be seen literally spilling through the cracks. But where is the heat coming from? Enceladus is too far from the sun to be warmed by its rays. Yet it is also too small to be able to hold on to the internal heat it acquired when it formed billions of years ago. Instead, scientists suspect that somehow Enceladus is gaining additional heat from the gravitational pull of Saturn. But whatever is heating the moon, evidence is mounting that it's been going on for a long time. For example, Cassini has revealed that a blanket of snow made up of icy particles from the geysers is building up on the moon's surface. In some areas, the blanket is 100 meters thick, an amount that scientists estimate would take 10 million years to accumulate. If Enceladus has been active for that long, it may be because beneath its icy surface lies an entire ocean of liquid water. If this is true, then the geysers of Enceladus represent the most direct evidence yet for liquid water beyond Earth. And where there is water, there could be life. But water is a dynamic substance that brings change wherever it turns up. That's why looking for change may ultimately be the best way to find water beyond Earth. In our solar system, no other planet has intrigued, excited, and misled astronomers more than Mars. Mars is the only planet with a solid surface that can be observed easily from Earth. And for generations, its rust-colored glow has beckoned would-be explorers. First with telescopes, and then with wave after wave of robot probes. What they have discovered is a world of dry rivers and ancient lake beds. A world where water flowed freely billions of years ago, forming mineral deposits and bubbling through the soil in hot springs. And it is also a world where water still exists, in frozen form, locked as permafrost in the Martian soil. But in all this exploring, is it possible we've missed the most important discovery of all? Mars is a remarkable world with a complex history in which water once played an important role. Today, spacecraft are orbiting around Mars and roving over its surface in an effort to piece that history together. But in the process, they are also turning up some unexpected clues that suggest there may be liquid water lurking on Mars today, and we can find it if we know where to look. Mars has received so much attention over the years, it may seem strange that only now are scientists beginning to spot these clues. But that is because for many decades, the exploration of Mars was a fleeting affair, with visiting spacecraft only surviving for a limited period of time. That changed starting in September of 1997, when Mars Global Surveyor arrived. It was the first of a new generation of orbiters that have had Mars under continuous surveillance ever since. And that is precisely what is needed to look for small-scale changes that could be a sign of water flowing near the Martian surface. At face value, such an idea seems misguided. After all, Mars is a freeze-dried world with an atmospheric pressure so low it's nearly a vacuum. Under such conditions, any liquid water on the surface would rapidly vaporize. But in June of 2000, scientists operating the camera on board Mars Global Surveyor reported an exciting find. In some of the tens of thousands of images, they found small gullies carved into the sides of canyons and crater walls. The gullies looked suspiciously like they were formed by water that seeped from the rock and flowed downhill before evaporating. And unlike those features formed where water flowed on Mars billions of years ago, the gullies looked recent, as if they were just formed. When they were first discovered, some scientists speculated that the gullies might be a sign that there are hidden reservoirs of underground water on Mars that occasionally spill onto the surface. It's a tantalizing possibility, one that became even more exciting when some of the gullies appeared to be changing from one year to the next. Perhaps water was responsible. But there was a catch. The gullies were typically found far from the equator, in craters or canyon walls that faced away from the sun. These cold and shaded places should be the least likely to yield liquid water. And that suggested another way to explain the gullies. Mars is so cold that during the winter months, the carbon dioxide in its thin atmosphere can settle onto the surface as frost. Such a buildup of CO2 could trigger landslides, simply by adding weight or by pushing up on rock and dust when it evaporates. But there remain cases that are difficult to explain. In 2011, scientists working with the Mars Reconnaissance Orbiter, a spacecraft with the most powerful camera sent to Mars yet, reported that the orbiter had spotted a curious phenomenon in Newton Crater in the southern hemisphere of Mars. Images taken several months apart showed dark streaks rolling down the crater walls and fanning out along the flatter ground below. More streaks appear as the southern spring turns to summer. Then they disappear again at winter's approach. It's tempting to think that water is the cause, darkening the soil as it runs downhill, like a wave creeping across dry sand. But the discolorations last for months, too long for liquid water to linger near the surface of Mars. Instead, water from melting ground ice may cause a chemical or physical change in the soil as it flows just below the surface. If scientists were to verify that liquid water can sometimes occur on Mars, even briefly, the implications are enormous, because that water might be all that's needed to sustain hidden colonies of Martian microbes. It's an incredible idea, one that could put an alien form of life within our grasp. But even as we imagine building more sophisticated machines that will further the quest for water on Mars, another kind of spacecraft has transformed the search for water in the universe by taking it to the stars. If there is one idea about the universe that is fundamental to all others, it's that no one place in the cosmos is truly unique. In every direction in space, there are atoms, stars, and galaxies. Just as there are here, and they obey the same laws of nature. This is an extremely profound thought, because it means that if life is possible here, we should also expect to find life elsewhere, wherever conditions are right. Conditions that include liquid water. Fortunately, space travel has given us a new set of tools for exploring beyond the solar system. They are orbiting telescopes that are making it possible to find planets around other stars. And they can even tell us if some of those planets show signs of having water. One such planet, designated HD 209458b, has been found circling a star similar to our Sun. Located 150 light-years away in the constellation Pegasus, it is the first planet outside our solar system to be observed crossing directly in front of the star that it orbits. Even though the planet is too faint to be seen directly, each time it does this, astronomers can measure how much the star's light dims and for how long. This has allowed them to calculate the planet's size and its distance from the star. But it can also reveal much more. As some of the star's light passes through the planet's atmosphere, it can be used to read the chemical signatures of the gases that are present there. Space telescopes have detected the signs of an extensive atmosphere around the planet, and they paint a portrait of a world that is unlike any in our own solar system. Heated by the relentless glare of a stellar inferno, the atmosphere of the planet has expanded, forming a long tail of gas escaping into space. Closer in, the atmosphere is subject to 1,000-degree temperatures and violent winds. At such extreme conditions, and lacking a solid surface, this planet is not expected to harbor life. But in analyzing its atmosphere, astronomers in 2007 made an important discovery. For the first time, they reported evidence for water vapor on a planet orbiting another star. This is exciting, if not a complete surprise. After all, water is one of the most common molecules in the universe. But seeing its signature in the atmosphere of so alien a world means that, in principle, water may also be detected on other planets that are far more similar to our own. The job of finding those planets falls to a highly specialized space telescope. This is Kepler. It is the first telescope with a reasonable chance of detecting another Earth. Kepler does this by staring continuously at a single patch of our Milky Way galaxy. By doing so, it can monitor over 100,000 stars at the same time. Every so often, one of those stars will dim for a few hours and then return to normal. If the dimming repeats at regular intervals, then astronomers know that Kepler has found a planet. One of Kepler's most exciting discoveries to date is a planet around a sun-like star simply called Kepler 22b. Kepler 22b orbits at about the same distance Earth orbits the Sun. Just the right distance for liquid water to exist, and possibly life. But Kepler 22b is also not like Earth. Instead, it is nearly 2.5 times the size of our planet. Astronomers call such a world a super-Earth. Kepler 22b could be made entirely of rock, or it could be a planet-wide ocean, a water world. Another example is Galizi 1214b, a world that circles a small red star only 40 light-years from our solar system. This planet is similar in size to Kepler 22b, but much closer to its star. This makes it easier to measure the planet's mass because of the gravitational pull it exerts on the star as it orbits. From observations of the star, astronomers can tell that the planet is not nearly massive enough to be made entirely of rock. Therefore, it is either a small, rocky world with a vast atmosphere or a true water world. If this is confirmed, then the notion of a planet made almost entirely of water will no longer be science fiction. It will instead be one of our nearest neighbors. When we search for water in our solar system and beyond, what we have found is the universe's remarkable capacity to surprise us. Instead of places that resemble Earth, we've discovered Martian gullies, geyser-spraying moons, and possibly ocean planets. What all of these findings point to is the incredible variety of environments in which liquid water can exist across the cosmos. On Earth, almost everywhere we find liquid water, we find life. If our world is any indication of conditions elsewhere, then ours is a universe teeming with life.